All right, so we have this wave and particle nature of an electron. And this is like it opens up so many questions. And really understanding the behavior of an electron would be an extremely powerful bit of information. And so we've done a lot of studying on it, or like as a scientific community. And it's hard to get information about electrons. And Heisenburg developed the Heisenburg uncertainty principle, which kind of explains why we can never why we're inherently limited in our knowledge of an electron's behavior. And so he was able to combine the work of some others and develop this idea that the product of the uncertainty in both the position and the speed of a particle would be inversely proportional to its mass. And so breaking that apart a little bit more, that means, so the uncertainty in the position is, if we decrease the amount of uncertainty we have in its position, it means we really know a lot more about exactly where something is, right? The more uncertainty you have, the more we're like, it's somewhere in this area. And then the uncertainty in the speed of a particle means that if we have low uncertainty, we have a really clear idea of how fast that particle is moving. And if we have a lot, we aren't so sure, right? So being able to measure and to know the uncertainty levels of both position and the speed of something, it is useful. So you want to decrease both of them. But because the product of them is inversely proportional to its mass, it means that as we decrease our mass, we cannot have the product of those two uncertainties be very, very small too, right? So the smaller the mass, the larger the uncertainty is maybe the better way to say it. So as mass decreases, uncertainty in position and speed increases, and the product of the two. So if we're trying to really learn one thing or the other, or both of them, like we're inherently limited because the electron is so small. It's one of the smallest bits of matter that we can detect. And so if it's that tiny, then we are going to have a lot of uncertainty. And so, okay, let's just focus in on one of them, right? Like we can get more and more information and less certainty on one piece, but it will increase the amount of uncertainty we have in the other. So as I am more certain about the position of an electron, I will dramatically increase my uncertainty about its speed, just because those product of those two has to be proportional, inversely proportional to its mass. It's related to its mass by this equation that we have written down here that we won't actually calculate anything with, but it explains this relationship, right? Um, and so that means we can't know enough information about the mass, or sorry, the position and the speed of a electron very accurately. Like its size prevents us from knowing that. And so that means that when we talk about the structure of the electrons in an atom, we have to talk with this uncertainty level that we deal with. And so we can't say things definitively. Instead, we're going to talk about electrons in an atom in terms of probability or likelihoods, because we have to balance out all of that uncertainty because it's such a small particle. And so we'll say, well, it has a probability of X of being in this region at this speed, things like that. And that means we're going to start talking about the atom in ways that feel, especially when you're first learning this, they sound very vague and hand wavy. And I can assure you, there's a lot of math to support the what we say, but like especially in the beginning, it seems like there isn't a lot of knowledge in that sense. And that's okay. We're going to use weird words like electron cloud to be like, just the general probability of being in this general space. And just know that there's a small probability that is always outside that space, and that we are just inherently limited in the amount of knowledge that we can have because of its size. Should have moved this slide earlier. So here's my electron cloud I was talking about. So since we're just looking at like probabilities of an electron being found in a region of space, that's what we can do. We can predict those probabilities. We're going to have this idea of an electron being likely to be in a space, but not something we're very sure of. And the greater that probability, we can call it the greater the probability density. finding the electron in that space. So as we move forward, talking about the modern picture of the atom, we are always going to be working in this realm of the slightly unknown.